Let me give you a quick introduction to piecewise function. Piecewise function is a function that consists n pieces. Each piece has its domain. So in general, I have a piecewise function f of x that equals to n pieces. So from f1, f2, and then all the way down to fn. So the first piece has a domain 1. The second piece is domain 2. I should say the first piece lives in domain 1. The second piece lives in domain 2. And the nth piece lives in domain n. So think about this. Let's say we have n families travel together. So when they go to a hotel, the first family lives in room 1, the second family lives in room 2, the third family lives in room 3, the nth family lives in room n. So when they get to a hotel, every family has their own room to live in. So that's one of the best way to think about piecewise function. So I have a big function, f of x. I cut this big function into little pieces, and then each piece has its own room to live in. For example, I have f of x equals to 3 pieces, negative 6 if x is less than negative 2, and then 1/3 x if x is between negative 2 and positive 3, and f of x is equals to 3 if x is greater than 3, and then my job is I want to evaluate this piecewise function at the indicated x value. So first one, f of negative 5, that means x is equals to negative 5, and then we know that x is equals to negative 5, that is less than negative 2, right? So that means we are taking the first piece. So when you plug in a negative 5, the first piece is equals to negative 6, and negative 6 is your final answer. And then the next piece is f of negative 3, so x equals to negative 3, that satisfy which inequality? The answer is the first one. So because negative 3 is less than negative 2, I am taking the first piece. So f of negative 3 is just equals to negative 6. The next one, f of negative 2, so is negative 2 less than negative 2? No, right? So negative 2, I'm going to write this for you. So x equals to negative 2 is in here, between x and 3. So negative 2 is equals to negative 2. So that's why we are taking the second piece. Then f of negative 2, that is equals to 1/3 times negative 2. Then you have negative 2 over 3. So in this piecewise function, when x is equals to negative 2, y is equals to negative 2 over 3. And then the next piece is f of 0. X is equals to 0 is in where? 0 is between negative 2 and 3, right? So that's why we are taking this middle piece. So f of 0 is equals to 1 over 3x. 1 over 3x, x becomes a 0, so that is equals to 0. So that means when x is equals to 0, y is equals to 0. All right, so let's do the next one. The next one we have f of 3. 3 is in which domain? X is equals to 3. Is 3 greater than 3? Nope. So that means the second piece. So is in here, between negative 2x and equals to 3. Right? 3 is equals to 3, so we take the second piece. When x is equals to 3, we plug in 3 to the second piece, then we get a 1. So when x is equals to 3, y is equals to 1. And then the last one, f of 7, so we have x equals to 7 greater than 3. Greater than 3, so we take the last piece, and then f of 7, that is just equals to 3, because in the last piece we have y equals to 3, always equals to 3. It doesn't matter what x is, right? But in terms of this problem, y is equals to 3 when x is greater than 3. So let's say the next one, I have f of 100, right? So x is equals to 100 is greater than 3, then f of 100 is equals to 3. Even though you change the 100 to 1 million, 1 million is greater than 3, so you take the last piece, so therefore y is equals to 3. Let's do one more. So this one, I have g of x equals to 4 pieces, and then I want to evaluate all of those. So the first one, g of negative 20. So g of negative 20, we have x equals to negative 20. So negative 20 is satisfy which inequality? That is less than negative 5, right? So we take the first piece. So we have g of negative 20, y is equals to negative 9. That is your answer. And then the next one, g of negative 5. So we have x equals to negative 5. Is negative 5 less than negative 5? Nope. Then that goes to the second pieces, right? So which is 2 plus 3x. So this is in between negative 5 and negative 1. So we are taking the second piece. Then g of negative 5, that is equals to 2 plus 3 times negative 5, that is 2 minus 15, so that is equals to negative 13. So that's the second piece. And then the next one, we have g of negative 4. So negative 4 goes where? X is equals to negative 4, and negative 4 is where? Is between negative 5 and negative 1, right? So negative 5 less than or equal to negative 4 less than or equal to negative 1. So we take the second piece, g of negative 4, that is equals to 2 plus 3 times negative 4, that is 2 plus, not plus, 2 minus 12, that is equals to negative 10. So we have 3 problems finished. Let's do the next one. The next one is g of negative 1. Okay, let's see if we can squeeze that over here. Probably not. G of negative 1, so this is x equals to negative 1, that satisfy the equal, right? Oh, actually, I make a mistake in this problem. I am glad that haven't affect the problem, that haven't affect any of these answers yet. So where is the mistake? So the mistake is right here. So fix that. Let's fix that together. I have a equals to negative 1. And this one there is equal to negative 1. So actually this is a pretty convenient mistake. So what happened when I put up equal on both inequality? That gives me a problem because when x is equals to negative 1, I don't know which inequality I have to take, right? So that gives me a problem. So to fix this problem, I am going to erase this negative 1. Okay, so just keep that as a less than. Then this goes to which inequality? The second one, negative 5 less than or equal to negative 1, this negative 1, and then less than or equal to negative 1. So we take the second piece, then g of negative 1 is equals to 2 plus 3 times negative 1, that is 2 minus 3, we get a negative 1. And then g of 0. G of 0, so 0 is between negative 1 and 6, right? So x equals to 0 is between negative 1 and 6. So we take the third piece. Then g of 0 is equals to 12 minus 4 times 0, that is equals to 12. And then 0.5. So x equals to 0.5, that is between 6 and negative 1. So that means we are taking the second piece. So we have g of 0.5, we plug in this to the, sorry, said the wrong thing. We are taking the third piece, 12 minus 4 times 0.5, that is 12 minus 2, which is equals to 10. So how many more do we have? We have 4 more. So this one I will have to cut the entire problem and then paste that down below, because otherwise you won't be able to see the problem anymore. So I am going to copy the whole thing and then bring it down here. Look how convenient that is. So now our job is we have to deal with these 4 evaluation. G of 6, so we have x equals to 6, so x equals to 6, so that satisfies the third inequality, negative 1 less than x less than or equal to 6, right? So 6 goes right here, and 6 is equals to 6. So we take the third piece, g of 6, that is equals to 12 minus 4 times 6. So that is 12 minus 24, that is equals to negative 12. Box the final answer. And then g of 8, so g of 8, that goes to the next one, right? So x is equals to 8, and that is greater than 10. So that goes to the last piece. So g of 8, you just plug in the a to the x. So do you see this? G of x just equals to x, right? So whatever x equals to, you plug in, then you get an 8. It is just that easy. And then the last two, g of 10, we can do this together, and 13. So we have x equals to 10 and x equals to 13. Which one is, oh, actually we cannot consider this together. So let me take a step back. I am going to do the g of 10 first. I will explain why we cannot just do it like this. So we should try this in a different color. So g of 10, right? So that means x equals to 10. Is x equals to 10 greater than 10? Greater than 10. The answer is no, right? 10 is not greater than 10. Then what do we do? Can we stuck the 10 right here? Can we say this? Yes or no? No, forget it. So what does that mean? That means the x equals to 10, that doesn't satisfy any domain. So x equals to 10 does not satisfy. So does not satisfy any domain. So what does that mean? That means g of 10 is undefined. I am not able to find a room when x is equals to 10. So every family has a room. If you are an outsider, you are from the middle of nowhere, you walk into the hotel and they will just tell you, I'm sorry, there is no room for you. Last one, G13. So G13, this is x equals to 13. Now that is greater than 10. You know what? Here, I was wrong the whole time. Okay, let's push the 13. Okay, I was wrong the whole time. You are probably laughing at me right now. Okay, let's fix this. X is equals to 8. All right, so this is clearly wrong. Cross that. So g of 8, this is x equals to 8. Is that greater than 10? The answer is no. Is x equals to 8 between -1 and 6? The answer is no. So let's move this one more time. Then what does that mean? That means when x is equals to 8, it doesn't satisfy any inequality. So when x is equals to 8, so x equals to 8 does not satisfy any domain. Therefore, g of 8 is undefined. All right, now we handle the last one. So the last one is greater than 10, then g of 13, then that is just equals to 13. All right, so that is the end of this video. If you think my instruction is helpful and clear, click the like, share the video for me, subscribe to my channel if you are on your way out. Appreciate for your help and support. I will catch you all in the next lesson. Signing out.